Time travel, the concept that has fueled countless science fiction tales and sparked endless debates among scientists and enthusiasts alike. Could we ever journey to the past or leap forward to see the distant future? The reality, as we understand it today, might disappoint dreamers. To understand time travel, we first need to grasp what time is. While it feels like a constant, ticking away in the background of our lives, time is anything but simple. Einstein's theory of relativity turned our understanding of time on its head. According to Einstein, time is not an absolute universal flow. Instead, it's relative. It changes depending on your speed and the gravitational forces around you. Let's unpack that. Imagine two people with identical clocks. One stays on Earth, while the other rockets into space near the speed of light. When the astronaut returns, their clock will show less time has passed compared to the one on Earth. This is called time dilation, and it's not just a theoretical idea. Scientists have measured this effect using ultra-precise atomic clocks on airplanes and satellites. GPS systems even account for time dilation to give you accurate directions. But here's the catch. This is time travel into the future, not the past. And while the effect is real, it's incredibly subtle. To experience significant time travel, you'd need speeds or gravitational fields far beyond anything humanity can achieve. It's a small window into the strange and flexible nature of time, but it's far from a Marty McFly-style trip in a DeLorean. Okay, let's switch gears to backward time travel. This is where things get really messy and paradoxes start to pile up. The most famous is the grandfather paradox. It's a thought experiment that challenges the very logic of time travel. Imagine you've invented a time machine and decide to visit the past. Out of curiosity, you meet your grandfather before he meets your grandmother. Let's say, for some reason, you prevent their relationship. If they never meet, your parent is never born, and neither are you. But if you're not born, how did you travel back in time to interfere in the first place? This paradox exposes a fundamental problem with traveling to the past. It breaks causality. Causality is the principle that cause leads to effect, a chain of events that makes logical sense. Without it, the fabric of reality starts to unravel. And it's not just about your hypothetical grandfather. Imagine a scenario where someone goes back in time to stop a natural disaster, but their actions inadvertently cause it. Such contradictions create loops that defy reason. Scientists have explored ways around these paradoxes. One theory suggests that time might be more like a branching tree, where every decision or action creates a new timeline. But this idea, while intriguing, remains unproven. As of now, paradoxes like this keep backward time travel firmly in the realm of fiction. If paradoxes aren't enough to stop your time machine dreams, let's talk about entropy. Entropy is a measure of disorder in a system, and it's one of the key principles of physics. The second law of thermodynamics states that entropy in an isolated system can only increase over time. What does this mean? Simply put, the universe is always moving toward greater disorder. Picture a sandcastle on the beach. Over time, waves and wind will erode it until it's just a pile of sand. You never see the sand spontaneously reorganize itself back into a castle. That's entropy at work. Now, apply this concept to the entire universe. The arrow of time, the forward progression we all experience, is essentially the increase of entropy. Time travel to the past would require reversing entropy, essentially unbreaking an egg or unmixing cream from coffee. This isn't just hard, it's against the fundamental laws of physics. Even if you had infinite energy, the idea of reversing entropy remains speculative at best. The universe seems to have a built-in one-way street, and it's pointing forward. Let's delve deeper into the microcosm of physics, the quantum world. Here, Heisenberg's uncertainty principle reigns supreme. This principle states that it's impossible to know both the exact position and momentum of a particle at the same time. At the quantum level, the universe is inherently fuzzy and unpredictable. So, how does this relate to time travel? Well, even if we could somehow build a time machine, the act of traveling through time might disrupt the delicate balance of quantum particles. This could introduce uncertainties that ripple outward, creating chaos in the timeline. It's like trying to play billiards, but every time you strike the cue ball, all the balls on the table jump randomly. Furthermore, quantum mechanics suggests that particles can exist in multiple states at once, a phenomenon known as superposition. If time travel were possible, how would superposition states be affected? Could you interact with past versions of particles or people without collapsing their quantum state? These questions highlight just how mind-bending and problematic time travel becomes when viewed through the lens of quantum physics. So, is all hope lost? Not entirely. While the challenges are immense, the quest to understand time travel isn't over. Scientists are still exploring the nature of time through theories like wormholes. A wormhole, also known as an Einstein-Rosen bridge, is a hypothetical shortcut through space-time. If such structures exist, they could theoretically allow for time travel. But here's the catch: wormholes would require massive amounts of exotic matter to remain stable. Exotic matter, with its negative energy density, is purely theoretical and has never been observed. Even if we could stabilize a wormhole, there's no guarantee it would allow for backward travel or be safe for humans to traverse. Another avenue of research involves the concept of closed, time-like curves, loops in space-time predicted by some solutions to Einstein's equations. These curves could, in theory, enable time travel. However, they're plagued by the same issues of paradoxes and causality we've discussed. Despite the roadblocks, the pursuit of understanding time itself is far from over. Advances in quantum physics and cosmology could one day reveal secrets we can't yet fathom. And who knows, perhaps the key to time travel lies in concepts we haven't even discovered. For now, though, the closest we'll get to time travel is through the pages of science fiction and the fascinating theories of modern science. Time travel might be impossible, but the journey to understand time itself is one of humanity's greatest adventures. Thanks for watching, and don't forget to like, subscribe, and join us for more explorations of science, physics, and the mysteries of the universe.